wait, no, hold on, that's the wrong one, isn't it? Yeah, right. Hello everyone, welcome to yet another live stream. Hi there. I'll be honest. I'm dying. Jeez, that was a great start. I'll be honest. I was actually fairly productive yesterday. Yeah, I was in fact. I have finished a fair bit of a segment of the video, I would say, and also my graphics card died, which tends to happen on Windows, which means I need to restart Premiere and open up Blender again. And today we will be obviously working on this, but at the same time there's another thing I would like to tackle, and that would be matrix multiplication. Yes, that's because another one of the videos, which will be pretty significant, will relate to bras and cats and operators, and they all can be thought of as matrices, so it'd be really convenient if we get a really good grasp on matrix multiplications. Now Ash, I have already asked Ash a couple of days ago about this, and we have gotten through the intuition behind it, and today I would just like to solidify that intuition. So basically matrix multiplication in terms of maps. Hi there Randy, how you doing? So we like to basically think of matrix multiplications as just map combinations, or map multiplication, whatever how we wanna go with it. And yeah, in that case we are also considering vectors to be a map. Shush, trust me, it will work. Well, I mean, no, actually vectors, I suppose. I genuinely don't know how bad it is to say we're considering vectors a map. It sounds bad on the surface. Doesn't matter. The point is, what we would like to do is we'd like to create some kind of... Well, basically, we would like to end up with this, you know? Like that. We'd like to end up with some really good explanation of this from a purely mathematical point of view, no physics. So, this will require a fair bit of effort, so let's get to rendering something in the background as this will all be going on. Alright. I haven't really eaten anything. My plan genuinely is to go to the shops after the stream. And so I'm gonna be doing the entire stream just on staying on nothing but water and good vibes. This is a bit of a wacky animation mode. So right here, what we would like to have actually is first of all Blender animation open. Maybe that would be nice. That would be a good start. And then, and then. What am I doing? I'm not thinking. Geez, derivatives 15. There we go. That's the right one. Basically, we'd like to select a line at x equals 0. Which is tricky because we've ever so slightly offset everything. Position-wise. Oh, we haven't! We have not! Well, would you look at that? Because then right here, we basically add to it. And we would add a 0 for now. But in reality, we'd add compare to 0, like this. And this would be on the y-axis, because basically anything at 0, yeah, there we go. And now as we slightly increase it, we have to be careful, because we do need to increase it slightly. We might also need to increase the amount of... Oh, that's gonna be annoying. That's gonna be annoying because in order to get this to work, then we need to increase this number, which will make this actually could have been worse. That conveys the point. The idea here being that this is meant to be a graph of h to x, and well, in that graph, for the equation of a derivative, we're dividing by h, which means it is undefined at h equals 0. That's the simple idea. Which I hope this conveys pretty well. Splendid. I am going like crazy with the video so far. Well, piss. Why is it okay, couple of problems then, because no wait, damn it, Windows. What I meant is this. Okay, yeah, that's the zoom out we're looking for. Zoom in. So this and then this. There we go. Okay, there we go. Splendid. Then we can zoom out and we could just change this equation, because this is right here the equation we're graphing right now. However, we wouldn't really want to graph this equation. We'd like to make it a bit more generalized, just to keep it a bit, you know, spicy and interesting. So we might as well use the sleight of hand of the fact that we're so zoomed in order to there we go. Fraction of f of x plus h minus f of x divided by h. This is the function we are graphing for an arbitrary f. Well, arbitrary f we can graph, but right now we're graphing like f squared. Splendid. There we go. How would this look? Hopefully not terrible. Ah, it does look kind of odd. And if I do it like this, then it melts with the background. It's damn it all off all the time. Unless we set up some kind of background. Like this. Or I guess I could use a volume. That would look so much nicer. That would look so much nicer. There we go. I know what to talk about. Did anything happen to you, Randy? There's always a topic. There's always a topic. Run me through a day. What happened? What happened today? Or what is going to happen? Any plans? No, this is sinking the limits. I wouldn't be liking sinking the limits. This, however, on the other hand, I think could be bearable. It isn't achieving the goal I had in mind at all. And I'm guessing it's because there is some geometry issues. I hope at least that's the reason, because that would be fixable. No plans today. Hey, why not? It's also a good kind of day. Not everything has to be planned. I've been often accused of being an overthinker. By now I'm also guessing nothing interesting did happen. Well done. It did look like a geometry issue then, because now this one is working splendid. Ever so slightly dim, and then what we can do is we can take this, there we go. It will make and now you can really nicely like set them to be in the background, whilst at the same time, oh my goodness, actually no, this is bad. A bit too gradual. We want the background to basically vanish into darkness so that it's not. Damn it! How are you still this visible? And if I do this, it just looks like garbage. There is no winning, genuinely, unless I move the limit. I'm such an idiot, I can just do that. I can just move the limit to some place that's more amenable. For now, temporarily, we can move it right here, like so. And then we can move this like so, this like so. There we go. And now we can just fine tune it. Let's try this. There, that's kind of the look I was hoping for. So now all the background is muted, so it won't really clash with the graph that we're trying to display, despite still being there, being present. And this is an absolutely atrocious angle. There we go. And I hope this renders fine. Splendid! Matrix multiplication! Okay, matrix multiplication is a topic that's absolutely atrocious, usually. Mainly because there are so many indices to go about. Now, I've personally not worked with tensors in physics. Had I worked with tensors, I imagine I would have a much better intuition and idea for indexing stuff. I have not, however, so this is going to be a pain. So, basically we're going to have x on the matrix, we're going to have y on the matrix, and this will take the form of lambda y x. Okay, it's yx first of all, which is bloody confusing already. This is xy, it's without it, but whatever. It doesn't make sense, I guess. When you have a vector, you only have one, then it doesn't matter. Yx. Now, when you multiply a matrix, A times B, it's not commutative because you get different maps. So, A times B gives you A in the x direction and B in the y direction. Which makes sense because when you have a bra and cat, you get a scalar. Yes. I don't mean to be that guy, but I feel like this should be notation for the scalars, just to keep it complete. But, so when we have this, x, actually let's do a, b, c, x, y, z. Then we do xa plus yb, well, yeah, plus zc, like this. If we flip it, however, what we get then is x, y, z, a, b, c. And then what we get is a matrix with first line times first line xa, then we get xb, xc, and then same thing for y and same thing for z. What if we multiply a 2 by 3? It's gonna get so horrible. Play this. B, C, D, F. God, this is so horrible. Fuck it. Right. And so you go right by down, right? Yeah, right by down. In a sum, right by down. Which means that UA plus XD. Correct? It should be... This is horrible. This is absolutely atrocious. Equality to... It would give us a matrix of How much actually? Hold on. What is the size of a new matrix? Three by three. I think this would give us a 3 by 3. In which case it would be this. Oh right, yeah, because each combination. So orange and yellow. Okay, this may be going somewhere. Trying to make examples, trying to create an intuition for why we're multiplying matrices this way. Because memorizing this is going to be bloody atrocious. So then we have this, which we're once again doing this way. I don't know if I'm onto something or if I'm just being delusional. I feel like I'm being onto something. I feel like I'm onto something because there is rhythm to it, which is we're trying to get each combination of columns and rows. Make it linear algebra. Linear algebra, because what we're doing here is we're basically, if we understand covectors, this feels like unlocking the key. Covectors. Because if we understand covector, singular, linear form. Fine, linear form. If we understand linear forms, basically what we need to understand is this. Now we use a couple might as well. A, B, X, Y. And if we understand this, then we're gonna bloody nail it. Okay, the problem is that Wikipedia pages for mathematics are famous for being horrible. So, parsing through this. Although, wait, alpha and then each vector. So what now? Alpha u. A couple of things there, because so what? This is so confusing. Okay, this is ax plus by. Okay. I know I'm going slowly, but and it doesn't seem like I'm doing actually anything, but that's because I am thinking about it intensely, and it's a headache is the only way I can describe it. Massive, giant, enormous headache. I guess W X Y Z in this case. A W, because we flipped it, right? A W plus BX. This one will be C. Oh wait, is it going that way? No, it's still gonna be A Y plus BZ, right? Headache, massive headache, massive headache. Okay. Okay, so the second one is going to be A11, B12, it was Y and X, correct? Y and X, yes. So second X, that's correct. Plus A12 plus B times B22. X and Y, so we're still doing it from the first row, but it's gonna be B, so it's gonna be first this times this as this one, and then the green one is second X by 2 by this one. AX BZ. Hi there, Remy. How you doing? Oh, why did it? AX BZ. Oh, right, because I'm an idiot. That's why. Oh, hi there, Remy. How you doing? Jeez.
You said that just now.
I know I did. I just didn't process it the first time. This is awful. I hate this. Oh. No, but do answer. This is that's because I haven't got an answer. So
Good.
that's not a satisfactory answer. Oh, jeez. Well, that's all you're gonna give me. Then I'm glad it's been good. I'm really glad it's been good.
Yeah. Are you doing mattresses or?
Yes, I'm well, doing is optimistic. I am trying to understand matrix multiplication. Struggling, failing.
Ouch. Okay.
It's going column to row, and then with each progressing column, we progress the column of the second matrix. With each progressing the row, we progress the row of the first matrix. Why? It has something to do with the linear form. Okay, first animation, let's do that. Anyway, yeah. So. Bad, am I right? Anyhow. I'm really hungry, I haven't eaten anything yet. It's wildly distracting.
Maybe do eat then.
Well, no, indeed, I need to go out and buy food. And if I go out and buy food, then I won't be able to stream. So I need to stream first. It's all planned out, that noggin of mine. The chaos that is there, it makes sense. Somewhat. Oh, half of it is underground. Well, that's brilliant. I would like to retract the statement about it making sense. And copy it like this. Splendid. There we go. go, and there we go. And what this will hopefully do is, I hope, it will be able to visualize limits in a beautiful manner. So there we go. Now we have two blue lines. It's kind of hard to see, but you have to trust me that they are in fact blue. And we just reduce them to 0. Oh yeah, we subtract from it at the very end. Well, that isn't gonna cut it. That just simply not gonna cut it. All of it is such a mess. Alright, this. There we go. Splendid. Randy, so yeah. There's really nothing happened to you this day. Because I swear, if we don't, like, I get what you're saying, Randy. If we don't get up a conversation topic, the entire stream is gonna be me trying to deal with matrices, and no one wants to see that. We need something. Alright, message received. Let's get back to matrices then. So, linear forms. So this would be a light breeze breed. Okay. We've got, in mathematics, a linear form, also known as linear functional, a one form or a covector, is a linear map from a vector space to its field of scalars, often real numbers or complex numbers. What does it mean to have its field of scalars? What is the difference between its field of scalars versus a field of scalars? Oh, that could be actually a field of scalars I multiply by the basis vectors. Oh, that actually makes sense. That could actually make sense. Define pointwise. What does exactly pointwise mean? In the case, certain property is defined by considering each value of some function. Right. A space called dual space of V or something like the algebraic dual space of V. And a topological dual space is also considered. It is often denoted homology of Vk, or when the field K is understood, V asterisk suite. All the notations are used. I am not particularly interested in them. What I am interested in is dual vectors and bilinear forms. Every non-generated bilinear form on a finite dimensional vector space V induces an isomorphism. I feel like I'm listening to Lemon. To V stars such as V stars such as this. Okay, splendid. I don't know. Fine. Listen. Matrices it is then. It's 5 in the morning. Are you trying to fall asleep or unable to fall asleep? Well, are you unable to fall asleep or trying not to fall asleep? There we go. Because that are usually the two reasons why someone is awake at 5 in the morning. Oh, David, Ash is busy right now. I don't want to just call him over, but I might have to. What's the, I'm sorry, what? Okay, so that base of... No, that makes sense. That actually makes sense, because what this would effectively translate to is like, if I am not mistaken, 1 0, well, that's not a 10. 1 0 1 0 is 1, but 1 0 by 0 1 is 0. I was trying to write down the more general way, but now I realized we only have 2 dimensions. That ain't gonna fly. That makes sense. That's what the basis of bloody hell. Or maybe what I'm looking for is the point of a dot. No, I'm not looking for a point of a dot product, because matrix multiplications works for both for the inner product and the outer. I'm fine. Sounds a hot star operator. I genuinely feel like I'm listening to Lemon again. Nothing is Lemon Sure's great, but goodness gracious me, this is bringing back some rough memories. I don't wanna hear about Stokes' theorem again. Whichever one of them, Navier-Stokes, I don't remember which one of them. I'm sorry. Suppose that X is a vector space of a C. Restricting scalar multiplication to R gives rise to a real vector space called the realification. That's not a word. And there's also complexification. Even worse.
That's like some of the main reasons I don't like to read Wikipedia articles on mathematics.
They are terrible. They really are.
You need to have like 500 pages of foreground knowledge to even read one sentence.
Yeah. And also, realification links to complexification. Hi there, figure. Hi there, figure. Hello on this fruitful day. Well, we shall see how it will be. I just didn't go to sleep. Alright. Well, I just want to know, Randy, what kind of live stream I should shoot for. For the live stream that will put you to sleep, or the live stream that will keep you awake. You know, I want to know what I should go for. I should go for the energetical. You know what? I'm gonna matrix multiplication and just hope that there is a really good LibreText article on the topic. WikiHow. How to multiply matrices 6 steps with pictures. Cheers.
For some reason, I always like to watch videos of that. So there's a live explanation.
Yeah, because live expressions are better. What I find funny is just that the text with pictures for the matrix multiplication. Wait, why are there 2 minus signs? Why is that minus 4?
I think that's just 4. I have no idea.
Matrices, yeah, multiplication to matrices. This is not helping. Okay, fine. I'm gonna do something which is highly advised not to do, not to be done, and that is I'm gonna try to use my brain. The sound gasp was phenomenal. Alright. The key here lies in the fact that it's linear algebra. I am so confident that that is the key, the secret to unlocking matrix multiplication. What are you working on? I'm trying to figure out the intuition behind the matrix multiplication. We already had this, which is basically map to a map to a map to a map. But right now I'm looking for a slightly different one. That was like purely mathematical. This one will be more like applied mathematical. Because I wasn't sleepy, nor am I now. And you know what? Cheers to that. Hey, been there. In that case, I won't tune the stream to anything specific, just gonna do the general make it. And as such, we have a matrix. Oh, once again, even simpler. We have a covector. Look at me using fancy words. And a vector. X and Y. What we get from this is AX plus B Y. Because column times row, yes. Why? Well, it's because as we increase on the x-axis, for each one unit on the x-axis, maybe that's how we should think about it. In each one unit on the x-axis, we're moving a units up, and each one unit on the y-axis, we're moving b units up. I feel like I'm walking in circles. What's the definition of insanity again? Okay, let's move this to the side. And let's begin that bad boy. A, B, C, D, W, X, Y, Z. There we go. Now, what we're going to get from this is, in fact, column by row, A, W plus BX. Then right here we're going to get AY plus BZ. I'm gonna need to double check it again because I'm not certain. It's terrible. CW plus DX and then CY plus DZ. Okay, let's double check this right away. Because if I am correct with this, then I may almost maybe potentially have an idea. I don't know, I'm checking on this. Matrix multiplication. And I misspelled it. This. Alright, splendid. Y and X, which means it's this and this, X, Y, and then scalar. Now, this should be from 1, 1, 1, 1, so A and W, that's correct, up to 1, N, and 1, so 1, 2, which means B, 2, 1, X, that's correct. This should be 1, 1, 1, this should be 1, 1, 1, 2, that's correct, to 1, 2, yes, 2, 2, that is also correct. This should be, I'm not having fun. 2, 1, that's correct, times 1, 1, that's correct, up to 2, 1, that's correct, and then 2, 2, that's also correct. And this should be 2, 1, yep, times 1, 2, So we imagine it basically. What we do is we take a column, we create like a hyper table. Just trust me on this. What we're doing is we're creating like a hyper table like this, divide into rows and columns, and then we divide these basically into their own covectors A, B, C, D, and then W, X, Y, Z. And then what we do is we just do the thing, which is we just inner product them for each element. This is good. I shouldn't use the X because I don't know.
That makes sense.
Tic-tac-toe. Yes. I hope. I really hope it makes sense. Now. Oh wait, that's a tensor product. I can't do. Why can I not find a single like random symbol that would fit here? I don't know. Colon free. Doesn't matter. There we go. Allow colon free to represent the product, the suite. Okay. Now. Progress. All that's left. All that's left is each one means on their own. I don't think it has deeper meaning. I think that's just it. I think it's just.
Okay, then you have the products there in the squares there, and what then? What happens then?
They're like linear. That's the pickle is that they're not product. The pickle is that I don't understand linear algebra. Honestly, that's the underlying issue here. Basically, like linear algebra stems from the idea that you can solve that there's like a better way to solve I forgot the word. It starts with C. Jeez, give me come my brain, I'm genuinely overheating right now. Whew. And then people wonder why sleep is important, the mathematics. Then people wonder why mathematicians go mad. I'm honestly surprised they can stay sane at all. Well,
Same.
the whole idea behind linear algebra stems from the fact that you can solve systems of linear equations, all of them at the same time. That's the idea. So the reason why I use matrices is because matrices basically allow you to solve multiple linear equations all at once. What do you need the matrix multiplication? It's quantum mechanics, simple stuff. Basically, quantum mechanics becomes just 20 times easier if you understand matrix multiplication. Because then you have all this funky stuff. You have like all of them funky equations. Really, really funky equations. I appreciate the flowers, by the way. I really love it.
I need to pack them. Don't have my drawing tablet right now, but that doesn't stop me.
I think I have the left one. It looks really, really good. You know what? In fact, I'm gonna write out the equation next to it. So, basically, hold on, let me find something that's not too horrendous. For example, jeez, it's not easy to find an example, but let's say that you have something like minus h bar squared by 2m times partial squared in relation to x. Oh, sorry, the square should be after the x, that's right. Plus v of x. And then you have that, brackets, and then let's do this for now, simply because I can't be bothered, to be honest. There we go. The whole point here is that this equation can be written out to be even more annoying if you only want to use wave functions, but it can also be written down like as following. It can be just... Okay, hold on, because the whiteboard's not cooperating. There we go. It can be also written down as just this. And I would argue this is a bit simpler. And in this case, this is a dual vector, this is a matrix, and this is a vector. So this is just matrix multiplication. That's it. That's all it is. You can write out all of these annoying, terrible equations as just matrix multiplication. You can think of them as matrix multiplications, which is even better. The pickle being that it only helps if you understand goddamn matrix multiplications, which I do not. Now you may be wondering, make it. If you don't understand matrix multiplications, why are you making a video on it? That's a fair point. Hey, let's understand linear equations. Amy, how was your day? I'm fine.
What?
I'm losing my mind. After this Discord whiteboard moment. I like the idea that Ash is going to eventually get back to his whiteboard and just see this out of context.
Yeah.
I think you will appreciate this whiteboard. It's just a sum of two linear functions, which is also a linear function. That's saying nothing. I keep thinking I have this eureka moment, but every single time it's just nothing. I'm too sober for this. Let me have a think. Just one. Derivatives! Derivatives as linear forms. Please, let this be something. Derivatives linear operators. Oh! Yes, did I... Am I onto something? That might have been a genuine eureka moment. Oh damn it, I don't want to read through Wikipedia page on it. Did you get more information about the system of linear equations and its solutions? Yes. Hi, the complex string, by the way, hi. Of any linear combination of functions equals the same linear combination of derivatives of the functions. Okay, time to take another 3 business days just to pass that single sentence. Okay, hold on, I'm just... In calculus, the derivative of any linear combination of functions. So when you take functions, you add them up. You get... Wait, no, that's trivial. What am I talking about? Also, it's linear combination or superposition because when... I just want to make a joke, I'm gonna take back and I'm gonna go with the tamer version. Physicists and mathematicians are just in a constant fight for every... They always need their own names for stuff. You have covectors if you're doing mathematics, dual vectors if you're doing physics, they're the same goddamn thing. You have linear combinations if you're doing mathematics, superposition if you're doing physics, same thing.
Yeah, that's pretty often in science, not just physics and mathematics.
Yeah,
it's also
but
in medicine.
It's especially funny in physics and mathematics though, because they are the same exact thing. Like, just by definition, they are the same thing, but they just instantly call them different. Actually, in medicine, what do you mean by that?
Like adrenaline and epinephrine. It's literally the same thing.
Oh yeah. Biochemists also feel the need to. Or I suppose in this case it would be more medicine. I feel the need to differentiate itself from biomedicine. I suppose when it comes to things like epinephrine. I feel like biochemists have a more solid right to it, I suppose.
I mean, it kind of stems from the same thing. Like, adrenaline comes from the here. It's like, hold up, I forgot. It comes from that one organ, adrenal glands. Oh my god, I forgot. And epinephrine also is like adrenal glands or something. Nephros here. Spleen?
It might be.
Why is my Google on German? I hate Google. Oh yeah, kidney.
Kidneys? Wait.
Epinephrine comes from Greek, epi, upon, meaning upon, and nephros, meaning kidney, meaning upon the kidney, referencing its production in the adrenal glands
That's
sitting atop.
a pretty comical name, actually. All things considered. Adrenaline comes from above the kidneys. That feels so. Who designed the human body? That makes no sense. That makes no sense.
There's a lot of wacky biology that doesn't make sense. Nobody designed it. It's just like it designed itself over millions of years with all its faults and yeah.
It is funny that. I'm sorry, I just can't go over the adrenaline. I don't know why it weirded me out so much that adrenaline comes from above the kidneys, but it just did for some reason. But yeah, it's so Greek. I mean, okay, Greek versus Latin is a common one, isn't it? Because there is epidermis and hypodermis. Wait, is it epidermis and hypodermis? I think so. I remember I was always bothered by epidermis because I preferred hypodermis and in hypodermis. I thought there would have been just a much nicer combination. But it's epidermis and it's the subcutaneous layer. Those are the two names. Because, yeah, so you have the dermis, right? You have the dermis, then above it you have epidermis, which stands for, above dermis, and then below it you have the subcutaneous layer. Or the subcutis. Just to double check. Subcutaneous tissue, sorry. Because it's Latin for beneath the skin, whilst it's used Greek for epidermis, right? Wait, is epidermis Greek? Let me double check again. I don't want to get banned for medical misinformation again. It does not state. Ah, the shading is loading. I can't draw. I find these things impressive. Hold on. Am I... This is what going crazy must feel like. always complains about the way I wrote my B's, so there we go. AB is equal to C. I'm doing groundbreaking mathematics here. Then all the colors are inverted. Only now they hit me. I like that. I like how this entire whiteboard starts off so lovely and then gets so much worse the lower you go. It starts off with really lovely flowers and then you go down, there's just madness.
Yeah, the descent into madness, I just wanted to say that.
Let's try something. Let's try this. C T is equal to E. There we go. The stomach's on the left. Oh, don't keep just messing me about with medicine facts. Before Matrix, what were you learning? What do you mean today? Nothing. I was just working on the video. Well, I still should be working on the video, in fact. What? I really like that. I do like it.
I am making up stuff. Alien plants.
I know it's a bit of a tangent, but I just need to get that information out there. If we weren't used to grapes, we would consider them to be alien. I would just like to. I just want to. Yeah, I just want to mention that fact. When you imagine, I find it so comical because in most of fiction, most of science fiction, whenever an author tries to create like an alien planet and tries to create fruits on those alien planets, 9 times out of 10 there's grapes. Because I mean, think about it. Look at grapes. They look alien. They look like something from an alien planet. If you really try to like not get used to them, get unused from them, then they do look just like. I mean, look at it. It's a whole bunch of red just balls on the thing.
Balls.
Am I alone in this?
The wax on it makes them look a bit weird too.
Yeah. Am I the crazy one here? Am I the only one who thinks that grapes look alien?
Probably not. Do you like green grapes or red grapes more?
That depends. That does.
Do you even like fruit?
I love fruit. Fruit is brilliant. My only qualm with fruit is that it's bloody expensive, and I love grapes. There is a certain kind of grapes. Well, I don't like the cold climate black grapes because they're just really sour and they're disgusting. However, warm climate red grapes are delicious. Green grapes, I've never had green grapes treat me bad. Hi, the macaroni.
Hi.
I've never had green grapes treat me bad, so I am usually more leaning towards green grapes. But there are also some pretty good like yellow grapes. I don't know if that's what they're called, but they're just really good, really sweet. Well, not this, like yellow brownish. They're these perfect spheres, and they're just there we go. This is what they look like. Yeah, they're just really sweet and lovely.
Never seen yellow grapes.
Yeah, they're a bit odd. But I know someone who has them. They also have black raspberries, which I also find wacky.
Got myself a coon can of white.
Is that one of your 24
Oh, yeah.
liters?
That reminds me of a picture I saw on Reddit. Hold up. Oh no.
By each one. So it would be kind of like you have x and y. It would be kind of like x first basis plus y second basis. And if we just disregard the bases, that's a dumb thing to say, make it. If I do A and B like this. That was audible. Goodness gracious me.
Yeah.
What?
That was audible. I felt that.
What did you do?
I felt that slap in my soul. Oof.
Oh, the
That
one
was-
I did.
Oh. What a
Oh,
slur.
sorry. I'm drinking white.
Make it.
You have to excuse me, I just did cardio.
Oh, good for you.
I
Have to
hate
climb
cardio
mountains
so
soon.
much.
Same, but I gotta do it, otherwise I won't be able to climb Mont Blanc.
Ah.
Make it. Why'd you remove threads on Discord? It was because rule 20, no more threads.
No more things. I'll get in your hair.
No more fingers. Oh, fingers.
What?
Just kidding.
Hey, Vsauce, Michael here. Where are your fingers?
This is awful.
Also, can you hear the printer in the background?
No, no.
Alright. Good.
This is awful. Is this what it is genuinely like to be a mathematician? You just sit, stare blankly into the distance and think.
I think that's what a philosopher is all about.
But I'm doing mathematics right now. And that is genuinely...
So you're doing mathematics philosophically.
I think mostly they have like friends that they learn it with.
Damn.
Sorry,
Unlike you.
but why do I want to? No,
You basically just said that...
I never had people like that.
You
I
basically
do.
just said that
I mean-
I'm like a mathematician without friends, which is a bar. That's...
I mean,
No,
the
you
first
have
rule
to.
about being a Make It Patreon is that you're not nice to make it.
No.
You can't be nice to make it if you're a Make It Patreon.
Such a headache. Why is this a linear... Because you
That's why I always say, let's annoy Make It.
Yeah, I know.
That doesn't mean.
Yeah, no, make it, schmake it.
Damn, macaroni! Macaroni! Get a hold of yourself!
Yeah?
Jeez!
No.
My goodness. I have
What
feelings,
is
you
with
know.
cheese? And
Damn.
what about them? Did they get out of the
Macaroni explained
closet?
to me yesterday stuff in paint.
All right. Yes,
oh
I
no!
did. Also, I forgot something,
Oh no!
but I think I can't explain that on stream.
That's ominous.
I gotta explain it in private, in general VC
That is
or somewhere else.
that is ominous. Really ominous.
No, because we would go too far into politics, and I don't want to go into politics on stream.
Very reasonable.
Because it's a non-political channel.
This is a brilliant fucking stream idea, I've gotta say. Just silently thinking. I'm leaving it for later. I'm leaving it for later because I cannot even.
Just the philosophy channel.
Just a live stream of just make it staring blankly into camera for 40 minutes. That was a genuine. I still want to do that stream. I'm going to do that stream.
Can I join?
Would you like to blankly stare into the camera for 40 minutes? Sure.
Yeah.
Me
That
too.
sounds like fun.
Hey, yeah, sure. Let's get everyone. It's a group of people blankly staring into a camera for 40 minutes.
Amazing.
So real.
Peak group activity.
Besties activity.
Yeah. Literally. I was like, no joke, I literally do that sometimes.
I'm sorry, you blankly stared at the camera for 40 minutes. Hey, I mean, once again, what would I know to was like have friends?
Yeah, if camera were people, yes.
You blankly stare at people. I respect it.
Yeah. That takes commitment.
Didn't
Imagine they are cameras.
hold on? Didn't Visas did that thing? Yeah, listing primes for 3 hours. that kind of live stream.
Oh my god, Sauce had an unlisted video I have hold of. I need to send that.
Yo.
Spicy.
Spicy.
Sounds fun. No music. Yeah, Randy. The only way you would be able to tell that it's not an image is because every now and then a small wisp of wind would like maybe blow the hair a bit. That's the only. It would be extremely eerie. That's the only way you would be able to tell it's not a still frame. Just completely dead silent, no movement whatsoever. With every now and then like a door creaking in the background. That sounds like
For some
fun.
footsteps.
Just muffled screams. Ah, that sounds like a good time.
So random. Deal. Oh, dear lord.
I know that video. Hold on.
Oh boy! No!
Boing.
I
We
need
have
to.
a cat that doesn't. She just. Yeah, that's what she do. She do be doing.
Yeah, you just sounded like HAL 9000 if they would meow. You know, the ominous red camera.
The red camera robot that from Space Odyssey.
Do you know the use of bubble sword? Because in 10 minutes of my teacher teaching, I already found a better one in my mind. Well, yeah, the purpose of bubble sword is to explain basic swords to people. It is famous for being inefficient. Like, its whole goal is usually to teach it to people and then ask them to come up with a better one or implement a better one.
Like Bogo Sword.
Yeah, or the non-sword. That's the one in which you just don't do anything and just wait until the computer randomly glitches into
Miracle
sorting.
Sword.
Miracle. That's a genuine thing, isn't it?
Yeah, you wait for a miracle to sort it. That's what it is.
In the age of
That-
modern
where you don't sort
technology,
it.
that I would like to call it the make it rule, which is in the age of modern technology, you can't come up with a topic idiotic enough for it not to be a thing.
Yes.
The make its principle.
You mean make its law or make its razor?
Make its razor.
Oh no!
If it's dumb enough, it exists. Sorry, what are bubble sorts? Well, there's one, and it's a type of sorting algorithm that's just famous for being inefficient, is all.
It checks
Wait, I didn't even
the
mention.
two things and compares them. If one is bigger, if they're not in the correct order, then it swaps. That's all it does. And then it goes to the next one and repeat ad nauseum or ad infinite till it's sorted. Pretty sure if I did that correctly.
Something like
Right?
that.
Alright.
And this is highly inefficient. Has an O function of the n squared, I think, or something like that. Which just mean it just means it's inefficient. It means bad. No, I can't. I'm so obsessive. I can't let go of the linear thing because it just. Is that the whole thing? Is that just a one big prank that mathematicians have pulled on people just to get them to lose their mind? Do you guys know color theory? If so, does red and blue have a stronger mathematical connection to red than red to any other color? I don't think color theory is mathematics.
Pretty sure that's true. That color theory isn't mathematics.
Yeah, I thought it was a thing in art. Because, I mean, in mathematics you can assign different values to colors, but there is no, like, correct assignment or something. You have XYZ, you have HSV, you have CMYK even. You have a lot of wacky stuff.
You have FSK,
FSK? Actually, I'm not familiar with that.
CXJ, NOG, DRF.
I don't think those are.
Bro fell for it.
You actually got me. You genuinely get me. I did look up FSK colors.
Alright, I gotta go.
Alright.
See you.
See ya, bye, have a good one.
I'm gonna absolutely annihilate myself and every trace I left behind.
Why do you
See ya.
always have to say that? I think color theory is about colors. As far as I'm aware, yes. It's just the way that colors work together and such. You can describe it mathematically. Lord knows. We went down the rabbit hole. I'm sorry, I'm getting flashbacks of that one time me, Reblax and Remco were trying to create a system to describe the base SI units using colors. And how it was, let me just say it certainly was something. Basically the pickle, long story short, basically wanted to create a system in which, first of all, every combination of units had a unique color. Second of all, the distance between similar units was smaller than distance between more different units. And third of all was... what was the third rule? No, I'm pretty certain those were the two. distance between similar units had to be. Oh yeah, and a third one was that that was kind of follows from the second, which is that there were no opposite base units because that wouldn't make sense, and we ended up trying to map. I think it was S6 onto a C, which is a 6-dimensional sphere onto a complex plane, if I recall correctly. It was an idea of all time, I would certainly describe it. You can assign colors to the wavelengths, which can be sort of mathematically, so you can sort based on color connections. Yeah, I mean, there's a lot of ways you can assign colors, just none of them are inherently correct or incorrect. Because you can assign colors to wavelengths, that is true. However, that's just how we see. I know it sounds dumb, but like, color isn't an inherent property of a wave. It is just a way to visualize the wave. Because in the same way you can assign colors to anything. This just be a number. So for example, if you assign colors to wavelengths, then that only gives you the control of the hue, which would be the most similar to HSV sort of system. In the HSV system, you can think of the H as a wavelength, because it's a circle like this, going red, yellow, orange, green, light blue, blue, purple. In the middle is white, and you usually can also imagine as a cone, and then going up or down of the cone is the brightness, going middle outwards is the saturation, and going around is the hue. And in this case, going around you could think of as the wavelength. Also, I think I found a way to prove Bach's conjecture, but I'm not 100% because I know my guess on how to do it, I think. Well, first let me look up the conjecture, and then I would love to hear that out. Conjecture. You mean the Goldbach's conjecture? Wait, you mean... Are you referring to the Goldbach's conjecture? Listen, Jack, I don't mean to rain on your parade, but you are referring to, and allow me to quote the Wikipedia page here, one of the oldest and best known unsolved problem in number theory and all of mathematics. I don't mean to rain on your parade here, but that's a bold claim. Considering how it's a 300-year-old unsolved maths problem. That's one of the best known unsolved maths problems. Go on! It's a bold claim to say the least. I would say so, yes. Jack is higher again, or absolutely delusional. I mean, I will say that if I have thought that I myself have solved one of the most difficult to solve problems of mathematics, my first assumption would be that I'm wrong. Personally. That's just me. Go on, Jack. I'm curious. I'm curious to hear you out. be a nice thing would be... You're not alone with that, I imagine. A really, really nice thing actually would be if we do equal to g of x and h. I think this genuinely could be quite a lovely visualization. At least I hope. I'm so behind on my work, I'm fine. Okay. I promised 4 videos, but I'm beginning to worry that I might not be able to deliver if I don't pick up the pace significantly soon. I don't want to overpromise. So the only other way is to pick up significantly soon. Alright, we're gonna take this as the slope, this as the x, this as the h. So before I start, I would like to say, please don't be mean. I'm not smart at all. I just think about stuff and I don't fully understand in the hope to come up with things. I don't mean to be mean. Listen, I don't mean to be mean here. All I'm saying is that you should temper your expectations. The only even prime is 2. So summing 2 with any other prime would give 4. Or an odd number. Other than 2, or prime number odd. So summing 2 primes don't equal 2 will give an even. Yeah, but I think the conjecture states that it works for every even number. Not that for every prime 2 prime numbers it works, only it works for every even number. The backwards. Okay. Now right here, let's do mesh, actually curve line, then we sample to 600, because might as well. Mesh. Let's have this be a and then set position. We're gonna slice this cake. Index. We math divided by this. There we go. Then we combine XYZ, and this will give us a range. Oh, we can plug them in the same exact way. I feel like it is easier to disprove. You mean the Goldbach's conjecture? I wouldn't call it easy, personally. To prove or disprove. I feel like easier is all. I don't even feel comfortable saying if it's easier to prove or disprove. Right here we subtract 0.5 and we multiply by 2. Whom did you just slap, Emmy? Who was it?
Tablet.
Oh, what he's done? What he's done this time?
Nothing. It was an accident.
I thought it was misbehaving.
I apologized telepathically already.
Oh,
Don't
I
worry.
see. I see. Understandable.
I'm not carry any emotional damage from it. I'm gonna make sure that everyone is okay.
It's easier to prove if you just prove the beginning of the number line to be true and extend to infinity. Makes sense? The beginning of the number line. I mean, it's talking specifically about every second object in the Z set. The beginning of number line, if it extends to infinity. Well, I mean, okay, so what I'm assuming you're saying is that you take your even numbers. Let me reread the conjecture and make sure I understand it. Every even number, natural number. Okay, so we have some kind of set of even numbers. Let's write it in white, right? And so then your method would be to, I don't know if that's the right notation, nor do I care. Your method would be to prove it for a couple of even numbers on the beginning as the first step, and then to prove that this extends to all even numbers. Is that what you mean? No. Okay, in that case I do not understand what you mean. It's easier to prove if you just prove the beginning of the number line to be true and extend to infinity. I do not know what you mean in that case. Index divided by 400. So this works on its own. Is the position that messes up? So make a number line from 1 to 20. Okay. Hold on, let me find some space. Oh, there. Beautiful. So we have a number line from 1 to 20. And the numbers we're interested in are 2, 4, 6, 8, 10, 12, 14, 16, 18. Right. Consider the number line made. Oh, it's because I'm an idiot. That's why it didn't work. Right. There we go. And then all of it is normalized because once again, I'm an idiot. No, this is true for up to 3 million numbers. Yeah, I mean, I suppose it's a relatively easy way to check. They're a relatively easy thing to check, as far as computation is concerned. I imagine it will be even more than millions, because it's, now that I think about it in my head, it's actually, you could implement a really quick algorithm for it. If you just, for each even number n, you take the primes from the top and the bottom, you run over them. Hi Darash, how you doing?
I'm doing good.
Speak of the maths and the mathematician will show up an hour and a half later.
Oh. I was plotting and scheming with someone.
I know, that's why I wasn't upset about it, don't worry. Wait, where do I
I'm
know
gonna be
that?
right back.
That's reasonable. What's this?
I feel like it can be proven. What can be proven? Wait.
I don't know if you want. Hi, the Remco. Hi.
That's why you wanted to leave Ash, I see.
No, no. Holy shit! You left him. Only even prime two, so summing two with any other prime would give 4 an odd number.
It's just.
Huh?
It's just a prime plus b prime equals n. That's what
Oh,
we
yeah,
need to prove,
sure.
right? Well, you need to prove that a plus b equals n, where a and b are a prime and n is an even number, yes. So, Ash, to fill you in on the context, Jack, you're familiar with the Goldbach's conjecture?
There's two conjectures that I always mix up. It's Goldbach and it's one other. So
The number
very safe number.
theory, every even number can be expressed as a sum of two primes.
Yeah, I am familiar with that.
I know how much you love numbers theory, so that's honestly
No.
criminal of you that you've forgotten. But Jack basically, not editorialized, thinks they found a proof.
They found a proof.
They think they found a proof.
Uh-huh. Well, I can maybe question mark look at it, but honestly, I hate number theory. I hate arithmetic functions. I hate arithmetic proofs. I do more analysis.
No, I think I found a way to prove Goldbach's conjecture. Now you've gotten me confused.
Prove it wrong or prove it right. That's also.
Also, I am confused about what's the difference between proving something and finding a way to prove it.
Prove it right. Uh-huh. It's one of the oldest. It states that every even natural number greater than equal is the sum.
Guys,
of its
what does
terms.
age like fine wine and age like milk mean? Well, age means exactly what it sounds like. When you age wine, wine basically usually gets better with time. Milk does not. That's the idea. Antonym
Unless
saying.
you like sweet milk.
Well, I mean, you may. I've never considered that actually. You know what? Fair point, Ash. I have never considered that.
Goldbach conjecture. Wait, so you said you have found a way to prove it right. What is your intended method?
I don't understand.
If you don't mind sharing, that is.
What is the difference between proving something and finding a way to prove it?
Proving something means that you have proved something.
Yeah.
Finding a way to prove something means that you have that.
You have found a way to prove something.
Yeah. Like, for example, a way to prove Goldbach's conjecture is probably not it, but like, hypothetically, if I were to say that I found a way to prove Goldbach's conjecture, I would say, for example, okay, take a look at this number system, and in this number system, everything is like multiplication is addition, and so you can express whether two numbers are prime based on whether they can be multiplied to be some number or something like that. Like,
Ah, I
that is
see.
a way.
I see.
Like, you have a mathematical structure and you're like, okay, maybe if I study this structure, I think the answer will pop out.
I see then.
That is a way to prove.
That makes sense.
Like, for example, Fermat's last theorem was the way to prove it is to look at other number systems, or part of it was like, it's a very large proof, but like part of it was looking at other number systems, ring theory, field theory, ring theory mainly, not field theory. So that is what I would classify as a way to solve a problem.
Divided by frequent. Oh, I'm still the normalized space. Did I nail it? No, why am I so way off? Why is this
Is it
division by
actually
4?
Indian? No, I am in fact not Indian.
No. Why is this division by 4? I don't understand. It's quite a fair bit confusing. Well, to be fair, all of it is quite a fair bit confusing. In this case, we should specify that f of x is equal to x. Oh, by the way, look at this neat little graph I made of a graph for a derivative. Which I hold on, I can remove the blue and the blue and the red lines because they're a bit confusing. But there we go. Does that make sense? Do I need to explain the graph? I can explain.
Yeah, sure, go ahead.
Like, this is just function g of x and h, and one direction is h, the other direction is x. And the reason why I made this graph is because remember earlier on when I didn't mention the limit when doing the derivatives?
Yes.
Well, I did tell you I was gonna be more mathematically precise. So in this segment, the reason why I mentioned this graph is because I showed that this entire graph is defined except for a line at h equals 0. And so I then specified that the way that we actually get the derivative is that we're approaching it from like both sides, like this. And from both sides, it actually approaches some kind of line, some kind of function. But at h equals 0, there is nothing because it's all undefined. So I am actually being relatively mathematically precise.
Yeah, that's fair. I mean, the reason why I don't object to any of the other things because they actually make for really nice visualizations.
Yeah, but I still don't want to just, especially when it goes to mathematics, I don't want to be imprecise. I feel like it's not mutually exclusive where you can both just have a very loose analogy and then you can have an exact explanation. I like that.
I have heard that primes get rare as numbers get higher, so we can just prove it gets so rare that there is no primes.
I don't think that is
No.
proven that they get rarer, is it? Or is it actually?
No, prime numbers do get rarer. That
Oh,
has
no.
been proved. Density of primes.
Okay.
But the thing is, like, your proof would be, by its very nature, probabilistic. And if you're talking about probabilistic proofs, then I think,
That's not a proof.
again, number theory is not my field, but I'm pretty sure there are probabilistic proofs that the Riemann hypothesis is correct. But
We have a name.
probabilistic proof is not what we want. We want a solid proof.
We have a name for probabilistic proof. It's called physics.
Okay.
Make a number line from 1 to 20, then prove that in 1 to 20, n equals a plus b. Then you can extend it from 3 to infinity for every even and non-even number. And you can verify looking at last digits. Yeah, so it's what, as I mentioned, which is you take first couple of numbers from the even number set and then you just extend it to infinity. Enemy couldn't handle us again.
Make a number line from 1 to 20, then prove that in 1 to 20, n is equal to a prime plus b prime.
Come back at me.
Then you can extend it from 3 to infinity for every even and non-even number. And you can verify it by looking at the last digit.
The bit of you can
Essentially,
verify by looking at the last digit, I don't understand. But other than that, yeah, so prove it on a small scale and then prove that it generalizes.
But generalizes how?
Yeah, that is the pickle here, isn't
I
it?
might just be being dumb because for the nth time, this is not my thing. Oh, let me think about this.
lambda. Oh wait, no, still.
No, unfortunately, I don't get it, but yeah.
I think it is just. In my idea, we
Yeah.
only need one n, and then the conjunction is false. Yeah, but you assume that it's false. If it's correct, then
If you look at Wikipedia, they say that they looked at all of the integers all the way to like something 10 to the power 18.
Yeah.
That's a pretty big fucking surge. So, I mean, brute forcing isn't working. If you can find a way to construct such an n, then you can easily prove it false. But
Yeah, like that's a brilliant and simple proof. If it's false,
if it's false, yeah.
there is a possibility that it might, in fact, not be false.
Yeah, and then you would just be on a wild goose chase.
99% of mathematicians quit right before they're about to compute the number that proves the Gamma's conjecture false.
But it's most likely true, though.
I don't know if it's most likely true or false, as I mentioned. I don't feel comfortable stating either one, because to me it's a toss-up. Like, the argument of density of primes seems very reasonable, but at the same time, I find it very weak.
No, it's probabilistic. I wouldn't be convinced.
Yeah. It's curious. It's one of those things where just... absolutely lucky. It must be a great job just, making conjectures, All you do is just make problems.
Yeah, they just make the world a worse.
Just invent problems. Banger job, absolutely. Honestly. I often like to say I'm a man of solutions. I'm glad to see that the position of man of problems also exists.
My idea, we can show that prime density gets lesser
Yeah,
than
but
n
once
bit.
again, that's probabilistic. If, like, correct me if I'm wrong, but prime density would mean that on average we would expect there to be a certain amount of primes. So
Kind
that's
of.
what I would expect density to mean, at least. Yes, whatever. We live in the one age. Prime density.
The prime number theorem states that the integral 1 over log t from 2 to t, log over 1 over log t from 2 to n approximates the number of prime numbers less than n better and better as it goes to infinity. Let me think about this more. Yeah, so
Whoa, wait, could you run that equation by me again?
greater doesn't mean 0. Yeah, it's always non-zero.
Hold on. Also, could you run that equation by me real quickly again?
Run that equation
Yeah,
by
yeah,
you.
yeah.
The prime number theorem states that integral. Actually, you're on whiteboard. I can just hop over to whiteboard.
Yeah. Because I think there might be one thing in there.
Why can't I use whiteboard? Oh, there we are. Yeah. Wait. Where do I write?
Anywhere, just
Okay, yeah, I'll write here.
all right.
Yeah. There are equivalent statements, I'm aware, but the one that I have in my head is essentially that. Wait, let me write it. An integral from 2 to n 1 over log e dt minus the number of primes less than n, less than or equal to n, I think,
Mm-hmm.
all divided over n. This function approaches 0 under the limit as n goes to infinity.
Okay, so as you increase, so what I'm gonna about to say will be extremely non-mathematical, but you know, for the sake of me understanding it, what we're saying is that under the infinite prime, right? Then oh wait, division by n, right? Because that's there to normalize it. Wait, hold on. Under the infinite, wait.
That's density. Wait, do I have the wrong equation?
The division by n throws me off.
Division by n throws you off?
Yeah, I don't understand why division by n. Because that looks like something to normalize it.
No, it's not normalization exactly. What the division by n is doing is essentially it's showing you that as you get farther and farther, as you drift off to infinity, essentially the primes get rarer and rarer. Is that it? Wait, I might be confusing things here.
No, that would
Again,
make sense,
not-
but that would make sense, but oh jeez, hold on.
The thing is this term up here in the denominator is never 0, okay? Because essentially this is what's happening. Wait, let me
Oh, so the
shrink
point
this
here
stuff
is
a
that
bit
this
more.
is kind of the largest, no, the smallest function we can find that is still
No, 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 no,
largest
no.
than the amount of primes.
I'll tell you.
Okay.
Just give me a second. Right?
Mhm.
So the idea is this is going to represent number of primes,
Yep.
right? And the number of primes, I don't know how the graph looks like. So if I draw the wrong graph, then please do correct me in the chats, right? But I'm pretty sure it grows something like this,
Mm-hmm.
right?
Yeah.
And now the thing is, so the green thing, what I'm writing here, is essentially this, right? This is the green thing that I'm writing here.
Yes.
Now the thing is, the integral term that I'm writing here, it's something like this.
So it's slightly smaller.
It doesn't matter that it's slightly smaller or not. The idea is okay, this is not even an accurate depiction. Like, give me a second here. So this is somewhere at 0, and this is somewhere at, like, let's say 10 to the power 10. So this is a very big graph,
Mm-hmm.
right? So if the number of primes look like this, then this looks like this, right? Roughly, approximately, maybe, right?
Mm-hmm.
And this red part is the integral. This red curve is the integral term I wrote here.
Yeah.
We just care about the absolute value of this, by the way. Like, it doesn't matter if it's less or more.
Yeah.
The only thing we care about is the difference. The idea here is, like, in the limit, right? The thing is that this difference never vanishes. In fact,
Okay.
what's funny is this difference if you look at its absolute value, it grows, right? So here, for example, the difference might be, let's say, approximately 25, right? So the function, the integral is giving you
But the
like
point is
25
that
more.
it's growing less than n.
Yeah, it's growing slower than n. And here,
Okay,
for
that
example,
makes
it might
sense.
give you an error of 700 primes. So it's giving you an error of 700 primes. But when you divide it by n, you're essentially like, in a way, you're looking at the percentage difference. And so when we write this equation out here, we're just saying that the percentage difference, that thing goes to zero. But the absolute difference, it in fact never vanishes. In fact, from the numbers that we have, for like very large numbers, this difference in absolute value actually grows. So this is actually a bad approximation, but the percentage difference tends to zero.
Okay. In that case, that makes sense. Now, what I was going to say is that if you consider some numbers, then consider some kind of even number, right? And
Yes.
logarithmic scale, and then let's say that the last prime number happened a really long time ago. All you need is only a very recent prime for this to still be hopefully valid. So once again, this is a logarithmic scale, so this will go from 0 to crazy ridiculous number. This gap could be massive, and well, okay, it couldn't be able to be this massive, but like this would be possible because we're dealing
I
with.
understand what the guy was saying before. Oh, okay. Yeah, do carry on.
Wait,
carry
who are you referring to in this case?
I don't know, but someone was like, okay, so if I can just prove that if n is my prime here, n is my even number here, then like the previously occurred prime is here. But then if you sum two primes, you can get at most here. You can never reach n. And that would be his disproof, essentially.
No, because Jack was
I
trying to
understand
prove
what you
it.
mean.
No, Jack was trying to prove it right. Jack was
No,
the
there
one.
was-
Jack was the one who said it. Unless you're referring to complex
No,
thing.
complex. Yeah, I'm referring to complex thing with this.
Okay, so you're referring to I heard that prime gets rare as number gets higher, so we can just prove it gets so rare that there is no prime since n divided by 2, where n is a large number. Is that what you're referring to?
Yeah.
Okay.
Yeah, that's what someone said, yeah.
Well, what I was gonna say is, hold on, let me actually think about this for a second. We have n. We have n by 2, and basically, in order for this to work, we need a prime after n by 2. That's what we need. We need at least one prime here for it to be on the table.
Sufficient condition.
What did you say?
One prime is not necessarily a sufficient
Oh,
condition. I
in
think.
this case, no, I'm not saying for this to be true. I'm saying for this to not be false.
Oh yeah, for this not to be false, yes.
Wait, no, not for this not to be false. For this to possibly not be false. There we go.
Yeah.
So the number of primes on this range, I don't feel like noting it, I can just say it. Number of primes on this range has to be at least 1. So all what we would need to show in order for this to be the case, we have a function, we have the pi. It was a pi, right? This right here, pi of n.
Yeah, this is
Pi of n by 2 minus pi of n has to be greater than 0.
yeah.
And that feels quite reasonable. But hold on, let me have a think. Because quite reasonable ain't gonna cut it for me. Basically what this means is
you
that
can look at this integral thing. If you believe this integral to be a good enough approximation and you put your trust in it, then writing pi 2 minus pi of n, right? That's essentially just evaluating the integral from n over 2 to n of 1 over log t.
wait, n over 2 to n?
Yeah, because
Oh,
you're
you
essentially
already-
subtracting 2.
Oh my goodness, yeah, I forgot you're good at mathematics. That makes sense.
And then and then this is like this, the absolute value of this thing. I don't even think it's negative, but just to be safe, the absolute value of this thing is definitely more than 0. So with this, you've automatically proved that this is But again, the problem is these are like this integration. It's approximate and it's also probabilistic.
Yeah, the problem is that, well, in my head, I don't know if I was answering correctly, but in my head the biggest issue is that this is continuous and this is discrete.
N is meant to be kind of like infinity. I mean, yes, N is meant to be infinity, but we're only talking about finite N because
Yeah, I don't know if
That's-
in my head, I don't know if I get it correctly, but isn't the biggest issue here that the integral is continuous, whilst the pi function is discrete? Because
yeah, this is the reason why this approximation even exists is because of a sub branch of number theory called analytic number theory, where you just take arithmetic functions and try to find analytic
Yeah.
functions that approximate it really, really well.
because our actual form wouldn't that would have to be greater than 0, it would have to be greater or equal to 1. Because
Yeah.
it cannot be 0.1, it can be anything like that.
yeah,
And
yeah,
then-
that's true.
And even then, the annoying bit is that I imagine this integral would dip below 1, but that doesn't matter because it actually would have to be that integral plus some kind of correction factor of delta m for mistake. Because there is...
We don't know such a correction factor.
Yeah, but that's what I'm
think
saying,
my-
like something to account for the gap between them.
yeah.
So we don't know what it is. So even if this dips below 1, that would still not disprove it because the correction factor is correct for it. So it's
Diverging. Yeah, it is diverging in the limit as n tends to infinity because there are infinite primes. It's supposed to be diverging. The difference is meant to be bounded, and it's supposed to, like, when divided by n equals to.
so see, complex thing is not quite as cut and dry. It's always a pickle.
Yeah. No, but I think if you want to, like, if n is even and you want to prove that there exists a prime number that is between that is like this, then I think this is provable. Like, hot take, I think this is provable.
The only problem is that
Like, concrete.
you mean that there exists a prime in this range.
I think, like, again, not a number theorist, but I think you can construct such a prime.
Because, like, that is... I do believe also that would be provable, simply because it wouldn't really affect the theory, the conjecture in any way.
Yeah.
It would effectively state that the conjecture is still maybe could be on the table.
Yeah, we are assuming that n is even. That's why n by 2 is...
Well, we have to assume that n is even.
yeah, it's Goldbach's conjecture.
If we don't assume that n is even, then the conjecture becomes rather... You know, if... I feel like, I could be wrong, but I feel like a plus b equals n, where n is not even, is provably false. I would say, personally, n equals 7. That's what I would personally say. What a fun detour. Actually, I'm now curious, as the n goes to... Is this something you could do on the fly, or is it non-trivial? Take a limit of this red integral as n approaches infinity.
No, it's a divergent integral.
Ah, nothing can be too good in life. Did you just make
Did you just make
infinity
infinity
a finite number? Where?
No.
I'm referring to the n, because n is meant to be kind of like an infinity only in this limit. Outside of that limit, we use the same character but to mean different things. In this case, on this side, we set n to basically be a limit as approaches infinity, and on this side, n is just meant to represent some kind of even number. You put n equals 7. Yeah, because I said
No.
that if you remove the condition that n has to be an even number, then you can prove the conjecture false. Because then you
No,
can
no, no.
set
This
from
is not a
7.
conjecture. This. Oh wait, the stream is behind. Fuck. That's why your words aren't matching what you're saying.
Yeah.
But the thing I wrote here, this holds for everything. This is called the prime number theorem.
Yeah, I know. I seconded
Yeah,
when I
just-
said
just a-
I seconded when I said that on this side we're referring to n as it approaches limit of infinity.
Yeah. Yeah, the limit is written here, albeit, yeah. Whatever. You guys are smart.
This one. Oh, in that case, I would have a question for you, Ash, if you don't mind. Because on the right,
Yes, do go on.
on the right where Emmy lies, there is yellow, and
Where?
it's been driving me a bit mad.
What is
This
this?
this was me trying to come up with a good explanation for matrix multiplication, and the thing I outlined in green, this, or in purple to be more fancy.
What's the problem?
The problem is I don't understand why. I don't understand why. That's the problem. Because like when it comes to matrix multiplication, what you're effectively doing is like right here at the bottom, right? You're dividing your matrix when you have A B equals C. What you're doing is you're slicing up your A into covectors and you're slicing your B into vectors, and then you're feeling it as such. That's effectively what you're doing. Where each one of these is just an inner product with a corresponding covector and vector.
Yes, essentially.
Yeah, the only thing I'm missing is what is a goddamn inner product between a covector and a vector? What is that meant to represent?
An inner product between a vector and a covector.
Yes. What is it supposed to represent?
Good question. I mean,
I think Goldbach's
an inner
conjecture.
product is just a map that takes two vectors to a real number.
I know what it is. What I'm struggling to understand is what it's meant to represent. What is it? Because like there are a lot of maps. Why this specific
Yeah.
one?
Well,
Like if you get what I mean, right? If you have R2, or in this case I would even say R4, because we have 4 real values, and you take a map to R1, there are like infinitely many maps that do that. Why specifically this one?
well, here's the funny thing. When you talk about a map, let's just call it omega.
Mhm.
From R4 to R1, you are correct that there are infinitely many of those. And what's funny is like each map omega corresponds to a vector, right? So each vector, each possible vector you could place here, right? It defines its own map from, in this case, R2 to R.
But what I'm saying is that each vector can define an infinitely many maps. So take for example. No. Just take for example AB.
Yes.
AB xy is equal to
Yes.
x to the power of a times y to the power of b. That's a different map. It's
That's
not
a
linear.
linear map.
Yeah, it's not linear. So is there only one linear map?
Is there only one linear map that AB XY?
Yeah.
Yes.
There's only one.
Yeah, corresponding to AB, there's only one.
Okay.
Like corresponding to this vector, there is only one linear map. in like all the possible maps. Like,
Hold on.
okay, it's better if we state it formally.
Yes.
So this is now terminology. I will explain it in a second.
Homology.
What you're essentially
yeah.
interested is this object, which are essentially all homomorphisms, structure preserving maps from R4 to R. Like, these are all the linear maps essentially from R4 to R.
Yes.
Okay. And there are infinitely many of them. Specifically, there are exactly how many of them? I think there are exactly R4 of them.
That would make sense.
Yes, there are exactly R4 such maps, where this is just like the norm of like R4, or like the number of elements in R4. It turns out that the number of vectors in R4 is also this. So there is a one-to-one correspondence between each vector and the map it induces from R4 to R.
You might have lost me.
And this is not a way you need to fix a basis.
Because in this case, you're talking. Okay, you said preserved structure. What kind of structure?
The linear structure.
Okay, could you
Linear
define
map structure.
define a linear structure for me?
Okay. Essentially, it should preserve that if you add two vectors before acting on by a covector, right?
Mm-hmm.
Then it should be the same as acting on the covector first, then adding them up.
Okay, so.
And if you scale, if you scale by some constant first, and then take the map, that should be exactly the same as taking the map first and then scaling them. That's what it means to preserve a linear structure.
Okay.
Why are you writing in bras and cats?
Because it's genuinely easier for me. I am B plus A C this. Also, only now did it hit me that I recognize this from taking, because without this probably you wouldn't be able to take out the Hamiltonian from between the position and the state. But so that's how do I slice this cake? There's so there's only one map that does that.
To corresponding in finite dimensions. In infinite dimensions, it also works, but only in Hilbert spaces and with a few more asterisks.
Wait, when
But
you say that there's only one map that does that, you are referring to a covector.
Yeah, every covector defines one map in this space. This is an
Okay,
entire space.
this is a four-dimensional vector, and what you're saying is that there are R4 different linear maps, and each one of these linear maps is a different covector.
Yes, there are R4 linear maps that take this that take a vector like this into R, and each covector corresponds to exactly one unique map.
Okay, that's good. Now
And
I
this
just
is
have
why you
even
can
bigger
represent-
headache.
And then this is why you can represent all linear functionals as covectors, because there is a one-to-one isomorphism. It's like bijective. There's a bijection between the space of all linear maps and the space of all vectors. This is precisely why you can represent functionals as covectors.
Meow.
Hi, Decatsi, hi.
Hello. How are you doing?
I'm doing fine. Take function. Okay, so basically f of v, I'm gonna use this notation for now. Fv, or f v plus w is equal to f of v plus f of w.
Yes.
And then the second requirement is the constant as well. Okay.
Yeah, and the third one that usually people don't state because you can derive it from the other two, but it's important to have, is that it should send the zero vector to the corresponding zero of the field or the vector space or whatever. Must map 0 to 0.
Mm-hmm. I imagine you can just do the constant, can you not? So lambda here, lambda here.
Yeah, you can, but it's not redundant to state this because it's a pretty important thing to be consciously aware of.
Okay. I think I've got it. I think I've got an explanation then. I'm not gonna do anything fancy, unfortunately, because I don't have an idea for anything fancy. Which is, what I'm going to say is I'm going to basically take this idea of linearity, just state it as something we want, and then just start with straight up v plus w, and that's it. But then I will...
Yeah.
So our linear function being just addition, that works. Last time I checked, addition was linear. And,
Yeah, addition.
and just go with that, but then expand it to say that, oh wait a minute, we can actually multiply v by a constant, and it still holds. And
Yeah.
even better, we can multiply b. We can multiply w by a constant. I am genuinely... I've reached the... Okay, if someone... This is not a fancy explanation by any means. It's extremely basic. But if someone would fucking put it this way to me months ago, that would have saved me so much time. Oh, this make... Because, like, with covectors, you always... Everyone... Always, when they're introduced to covectors, think of them as vectors, which makes sense because the vector of all the constants that the linear map can have. Okay, good.
Yeah.
Oh, jeez. I do have to say, I don't know if I'll be able to finish all 4 videos for the 9th of January, but they're gonna be pretty fucking damn good videos.
Yay.
I'm gonna go, because I still haven't eaten anything today. I'm gonna go to shops, buy myself some food, then I'm gonna get back and I'm going to script the entire video about... Will you make a video about Matrix? Yes, that's the reason why I've been bashing my head against the wall this entire stream. I will make a video about matrix multiplications, which will include the vectors and covectors as... I don't even know if I'll think of them as one matrices. Actually, I probably will. Yeah. But I'm gonna go now, because I am genuinely just famished. I'm feeling peckish. And I'll see you in a couple of hours.
Shops open. All my shops are closed
Wait. It's a Tuesday.
for New Year's.
Wait, what? No, I haven't checked if they're open. I assumed.
Yeah.
Uh-oh.
Then you should probably leave fast.
No, they're closing at 11:30.
Oh, okay. Good for you. Mine are closed.
Okay.
Oh, one of them is closed. Only one. In my area, there are 2 shops. One of them is closed. The other one is open. That's hilarious. Well, there are 2 shops that I normally shop at.
The only 2 shops that you know exist.
There are only 2 shops, and they're both near me.
Yes.
Will you start from beginning about the matrix? I will start from honestly basics about vectors and brass and cats. I will need to rewrite the entire script of the video actually because I'm not pleased with it so far. I will do a better job. Okay. And I suppose for now that'll be it. Thank you very so much for watching and have a great day. Bye.